Okay, this video is going to show you how we go about solving these covalent bonding and nomenclature problems. First, you see a chart that's very similar to the one that we completed for ionic bonding. Same principle, because covalent bonding has three similarities to ionic bonding. The first one is valence electrons. We're still talking about valence electrons here because that determines the number of additional electrons needed to form an octet. And we also do electron dot diagrams or electron dot structures to solve these. So here we go. Nitrogen. Nitrogen is atomic number 7, so it has 7 protons, 7 electrons. How many valence electrons does it have? It's in group 15. So we ignore the 1 and we know that it has 5 valence electrons. How many additional electrons is it needed to form an octet? It needs 3 more. Okay? Basically, to get from 5 to 8, you have to add 3. Okay? Now we're on to oxygen. Oxygen is element number 8. 8 protons, 8 electrons, and it's in group number 16. So it has 6 valence electrons, and it needs 2 more to have a full octet. Fluorine. 9. It's in group 17, so ignoring the 1, you have 7 valence electrons. It needs 1 more electron to have an octet. Phosphorus, element number 15. Electrons. Just like nitrogen, it has 5 valence electrons. It's in group 15. I'm sorry. Yeah, it's in group 15. And so you need to add 3 electrons to form an octet. Sulfur, it is in 16, and it has 6 valence electrons. So 2 electrons needed to form an octet. Chlorine. I'm going to pause and complete this chart. Okay, I've got my chart complete here. Yours should look like this. One of the things I wanted to show you was that fluorine, that's a halogen. Here are the other halogens right here. You notice they all in the same group, group 17, have 7 valence electrons and need to pick up 1 electron to form a complete octet. So there's your halogens. And also, if you have a look, you'll see that oxygen and sulfur are in the same period. Need the same number of electrons. And right there, nitrogen and phosphorus, same deal. Your special one is carbon. 4 electrons to form an octet. Now here's an interesting thing. These numbers over here, these numbers required to form an octet, also give you insight into how many bonds that the element is likely to form. Hydrogen, all of the halogens, can only form 1 bond, 1 covalent bond. Carbon is special. It can form 4. Phosphorus and nitrogen can form 3, and oxygen, sulfur like to form 2 bonds. Okay? So just a little bit of background there for you before we move forward. Now, to complete this worksheet, here are the instructions. Write the electron dot diagram of the elements. Make sure to use multiple atoms if required to satisfy the octet rule. What do I mean? Well, if you have oxygen that needs to pick up 2 electrons, you need to make sure that you have enough of the atoms it's bonding with to give it 2 more electrons. For instance, in H2O, you'll need to make sure you have 2 hydrogens to bond with oxygen. Then show the covalent bonds as lines. Don't forget, show unshared pairs. The bonds are lines. Write the formula of the compound produced, and then name the compound produced. Let's do the first one together. We have hydrogen. It's in group 1. It has 1 valence electron. We react it with fluorine. Let's do fluorine in a different color. Fluorine, which it's in group 17, 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. So, here are the 2 electrons that can be shared in a covalent bond between hydrogen and fluorine. These react to form this compound. Further, we can draw that like this. Okay? And now we need to name it. Let's page down to the naming conventions that I included on your worksheet. Covalent compounds are named in a different way than our ionic compounds. Many of them have common names like methane, ammonia, and water. However, simple covalent compounds are generally named by using prefixes to indicate how many atoms of each element. Okay? Also, the ending of the last, similar to ionic, the last element is changed to "ide." Okay? And they have this thing called most negative. Are we talking about most electronegative here? I believe we are. Prefixes used are simple: mono for 1, di for 2, tri for 3, tetra, penta, hexa, and so forth. The mono prefix is not used for the first element in the formula. For instance, carbon dioxide, we wouldn't call it monocarbon dioxide. We simply call it carbon dioxide. So you don't use that mono on the first element. And here we go. Sometimes you have to also drop an O and an A ending of those prefixes when you attach it to oxide, because oxide has a vowel in front. Let's go try to name this thing. Based on those naming conventions, we would call this hydrogen. Oops, always misspell fluoride. Fluoride. Now that's just like, fluoride is just like an ionic bond. Hydrogen fluoride. Here we go. Let's try this next one. Again, let's try it together. Now, we know that chlorine can only form 1 bond. We know that carbon can form up to 4. So we're going to put carbon in the center of our electron diagram. And it has 4 valence electrons. And you will add that to, let's draw chlorine in a different color. One, 2, 3, 4, 7. And there'll be 4 of those guys. And 1 up here. Kind of running out of room, sorry. 4. They react to form. Now I'm kind of taking a long route here. First few times we'll do this. We'll show the dot diagrams, and then we'll show the lines. We're going to always show our unshared pairs. And we're going to name it. Carbon has 4. Now, that is what is produced when 4 chlorines react with carbon. You'll notice that each chlorine atom has 8 electrons, and carbon has 8 electrons. Okay, covalently bonding. We can also show that as with lines here. Each of those lines represents a covalent bond, and don't forget the unshared pairs. A lot of work doing this. Here's something I forgot to do on the first one. I said, write the formula of the compound produced. This one, the formula, we'll write carbon first and chlorine second. Boy, that page numbers kind of confuse us. Let's do it right here. I'll do it in red just so that we have the color. Carbon and 4 chlorides. The name of this compound is carbon tetra, meaning 4, chloride. And up here, for the previous one, where I forgot to write the formula, it is HF. Pretty simple. I'll write that over here. HF, 1 hydrogen, 1 fluorine, known as hydrogen fluoride or hydrofluoric acid. We'll get into the acid later. Why don't you go ahead, I'm going to pause, and you go ahead and work a few yourself, and I'm going to do these by myself. Okay, I'm back, and you'll see water is done right here. You have 2 hydrogens and an oxygen, and if you were going to name that the scientific name, which no one actually calls it this, but it would be dihydrogen monoxide. Next one is chlorine. As you can see, chlorine actually has 7 electrons each, so they can share to form Cl2, which we know is chlorine gas. Next one I'm going to do, we'll do this one together. We have boron. I'll start way over here because I'm running out of room. Boron, we know it has how many valence electrons? It has 3 valence electrons. It's in group 13, and it has 1, 2, and 3 valence electrons. It bonds with chlorine. We know that chlorine has 7 valence electrons because it's in group 17, and it wants to add 1 electron to each atom. So that would be your dot structure for that chlorine, and this chlorine would be similar. And let me squeeze one in right here. What if I just make some space. I think you get the drift, but I'm just going to keep trying. Okay, and bonds together. Look at that. There are no unshared pairs on boron. Okay, no unshared pairs. We'll get into why that is important later. But what you're going to see is chlorine, 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 and boron in the middle, and a line between each, signifying the bond. That formula is boron, chlorine 3, and based on our nomenclature rules, this would be boron tri-chlorine. Tri meaning 3. There are 3 chlorines right there. I can do bromine and sulfur. Now, sulfur and phosphorus can be a little bit special, but I'm going to do them the regular way. Here we go. We have sulfur. Sulfur is in group 16. That means it has 6 valence electrons. And so 1, 2, 3, 4, 5, and let's just put the 6th in there. And what are we going to see? Probably what we're going to see is bromine, which has, in group 17, has 1, 2, 3, 4, 5, 6, and 7. All right, and over here, bromine has 1, 2, 3, 4, 5, 6, and 7. Now, when this looks structurally, bromine, sulfur, bromine, don't forget all of your unshared pairs. The formula is sulfur and bromine 2, and based on our naming conventions, it is sulfur dibromide. Bromine and oxygen, well, they do the exact same thing because oxygen is very similar to sulfur in that it has 1, 2, 3, 4, 5, and 6 electrons in its valence shell. And bromine, still with the 1, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. They both have 8. An octet, and so this is going to look something like this. And I suppose by now I've probably lost you and you have skipped to the end just to see what the solutions are. But don't forget your shared pairs. Oh, I did right here, didn't I? On that sulfur. Don't forget them because they do actually cause. So this one could be, I'm going to have to check this one. Is it oxygen dibromide or is it bromine oxide? And I guess it's oxygen dibromide. But I'm going to have to check that. And the last one, chlorine and phosphorus. In its most general form, phosphorus is going to have how many valence electrons? 5. It is in period 15. Sorry, group 15, so it has 5 valence electrons. 1, 2, 3, 4, and 5. And you know what's going to happen. I think this is probably pretty plain to see to you by now. And what we have is phosphorus with 1 unshared pair and 3 chlorines attached. And I'll make more space next time. Don't forget those unshared pairs on your chlorines. And I think we're just about done. The formula is phosphorus, and there are 3 chlorines. So it's PCl3, and the name is phosphorus trichloride. Now, I want you to be aware that phosphorus and sulfur can sometimes act differently, but generally this is what you're going to see.